Welcome back to Engineering 130 Lab 2, Part 2. So for the second circuit, we're going to be showing how to build that circuit, whether it is on Tinkercad or breadboard. So you're going to have 3 IC chips, one for the inverters, which is 74LS04, one that has AND gates, which is 08, and one that has OR gates. Although that I'm using only 2 or 1 from the chip, that's totally okay. So for the inverters, I'm going to be using 2 inverters. So I'm going to have here, I'll be using this one and this one for convenient. Also for the AND gates, I'll be using these 2. This is number 1, this is number 2. And for the OR gate, I'll be using this one, okay? Now, we have 2 inputs, A and B, so I'm assuming that I'll be using 2 switches, like number 1 and number 2. And I have only 1 output here, so that output is the one that's going to be connected to the output panel here to the left. Now, let's see how we're going to be connecting this, but before we go, let's go through. The output at this point is going to be A complement, okay, so that's the input to the AND gate. And the input here to the AND gate also is B complement. For the second AND gate on the bottom, the input is going to be B and A. Now, let's see how we're going to be. First, we need to create the A complement and the B complement using the inverters. So what I will do is I will take one of the switches and put them, for example, here. So this is going to be my A. And therefore, my output here is going to be A complement. I know that it's going to be A complement. So I'm just going to keep it there. So we're going to have 1, 2, I think we have 4 holes. The same thing here. And also here. These are the pins that you have on the output panels. So you connect this first one that's coming from the switch. I'm going to take the second one, okay, and connect it here. And that is my B. And I know that the output here is going to be the B complement. So now for the first AND gate, the first AND gate needs the 2 outputs of the A complement and the B complement. So what I will do is I'm going to take the output from here and the output from here to the 2 inputs of the first AND gate. And the output here is just going to be the star, the blue star. And I'm just going to put it the blue star. That's the output of this part, okay? Which is the A complement, B complement. Now, I'm going to leave that output for a while and try to find the output of the second AND gate or create that connection. So for my second AND gate, it's coming from the A and the B. And therefore, let me just do the green. So I'm going to be taking from the A and from the B. Okay, this is the A and this is the B. So I'm going to take one here from the B, take the other one from the A, connect it here, and this is going to be my second output. Okay, now the green star output and the blue one are the 2 inputs to the OR gate. So that OR gate here has 2 inputs. One of them is going to be coming from the green star. The other one is going to come from the blue star. So here's the blue. And here is the green output. It's an input to the OR gate. Now the final output, which is here, that's the output of the, okay, let me just, oops, I took that one out. So I have the green, that's the output of the green coming here. And the final thing is your output from here will go to the LED panel in between the 2 LEDs. So now when you do the switches on and off, you're going to notice that your LEDs here are turning red or green accordingly. And that is for circuit number 2. Moving to circuit number 3 is much easier, but it's better to rearrange your IC chips. If it's going to be difficult, you can just leave them around the same way you put it here. But I prefer to just move around a little bit because here I'm going to have the NOT, then the OR, and then the and. So to have the less number of cross wiring, I'm just putting them in the same order, having the NOT gate first and then the OR and then the AND. Now, if you look here, you're going to find that you have 3 inputs. So it means that I'll be using 3 switches, and only one of those inputs are going to be inverted, okay, to our complement. So it means that I need to use only one inverter, I need to use only one AND gate, and I need to use, one OR gate, and I need to use only one AND gate. So what I will do here is I'm going to be taking switch number 1, 2, and 3. So switch number 3 is going to be my R. Switch number 2 is going to be representing my P. Switch number 1 is going to be representing the T. So for the R, I will take it to the inverter. So now I have the R, and the output here is going to be the R complement. So whenever I want to use the R complement, I'm going to take an output from pin number 2 in this inverter. The same thing here for the P and R. Okay. Now let's take a look here at this OR gate. This OR gate has 2 inputs, one that's coming from R complement, it's coming from here, and the other one is coming from switch P. So I'm going to take it, this is input number P, that's an input to this OR gate, okay? And now the output here is just going to be the green star. Now, the last thing is your AND gate. This AND gate has 2 inputs, one that's directly coming from the switch. So I'm just going to put that in orange. So it's coming from switch number, I put the T as switch number 1. So that's my AND gate. And the second input is coming from the green star, the output of the OR. I'm putting it as an input to the second, an input to the AND gate. And finally, your final output of this AND gate is going to go to the output panel between the 2 LEDs. So whenever you're playing with the switches 1, 2, and 3 on and off, you're going to notice that it's turning red and green accordingly. So if you do it right, you should have the right light green or red. And that is the connections for the 3rd circuit of the lab. Thank you.